All right, so welcome you all to the malware analysis sessions. So I'll be having several sessions on this topic, malware analysis. So I'm assuming all you are starting from square one, but having knowledge of bit of assembly and reverse engineering would definitely help. Right. So basically, the need of malware analysis comes because there are plenty of malware outside uh, the world that we are living in. So and it's getting uh, stronger day by day, right? So there is a quite a necessity for proper malware analysis to bring it to identification. Otherwise, malware really affect us in our day-to-day life. So it can be to your own computer or to it can be to your phone, right? So these things really affect you. So there is a quite an opportunity in identifying malware. So we have got to deal with malware analysis, and there are so many different types of people who do malware analysis, right? So there are this need. So as an example, uh, organizations who do virus databases or virus signature databases, especially they have virus analysis, they do needs to identify malware. So there should be some place where the malware information should come, right? So most of the time, this organization, either Kaspersky or ESET or any other organization for that matter, McAfee. So those people have to identify the malware which is taken from the internet, and they have to analyze it. So once they analyze, they can figure out what type of malware is this particular code. Uh, and they can obviously look for answers and look for solutions, right? So that's basically what they do. Apart from that, of course, there are people who do research on exploit development. They do look at malware, uh, obviously because they do write malware, right? So their purpose or their target is to exploit a system. So malware is the better opportunity, or the malware is the option that they use to do that. So they are also they try to write malware and to analyze malware. They try to find out what can go wrong, what can go right. So they do a lot of malware analysis. Apart from that, there are security researchers try to figure out vulnerabilities and fixes. So there are a lot of organizations along the line of that. So they also do malware analysis, and because of pure interest, people do research on malware analysis, and it's a quite an interesting discipline. So all these are connected disciplines like reverse engineering, exploit development, malware analysis, security research. All these things are linked up. So you guys have done bit of everything now, bit of everything, not detail, but still you are in good hands to go into the next step. So some people might wonder how this is differ from what you have learned already. So there's no difference in that sense, because it's basically look at source code, look at dynamic behavior of a program code and memory allocations. So that's basically the base knowledge that you gathered in reverse engineering had to be used for even for malware analysis. But now you have to understand there are other specifics. So there can be Windows-based malware, there can be Linux-based malware. So there are different characteristics into a malware program. So it's basically, in a nutshell, it's the software code. So you guys have to do a bit of analysis on software. So then you can find out if it is a malware behavior. So obviously it's a malware. Right. So there are a lot of malware in outside world. So this is malware 101 in a way. So viruses. So that's probably the first type of malware. It's self-replicating and triggered by some action. So that's basically how it works. And then, of course, the other famous type of adware is there, but the most famous type would be worms. So worms are also self-replicating, and they try to capture the network services, and also they can self-replicate again. And then, of course, you have Trojans. You have heard the story of Trojan horse. So Trojan horses are basically malware hidden inside good programs. So if you get your keylogger, sorry, not the keylogger, as kind of a when you crack software. So when you want to get the key, software key, serial key, you get a file where you can basically use. Uh, so the Trojans can basically harm you because it's a malware hidden in a normal software like secretaries, serial key generators. And of course, this is something very common these days, which is ransomware. So there are so many different types of ransomware available. Mm. So the whole purpose is to hide or like blackmail you. Sort of they come into your computer and lock down things and they ask for money. It's a very common criteria again. So I'm not really moving or taking this discussion over and over on this because most of you are aware about these things. Right. So that part is clear, right? So but there are some other interesting malware types you guys have to study. As an example, a very good study option would be Stuxnet. So Stuxnet is a very special type of malware, which of course have the same features of a normal malware, but Stuxnet itself has its own story where basically we'll discuss about this later on, but it even resulted in a fight in between two countries. So some of these malware are pretty critical, and of course there are other things like code red really affected several machines in the world. So basically malware can be really really harmful, not only affecting an individual, it can go beyond that, right? Beyond that. All right, so now, of course, then if you try to understand the goals of malware analysis, so of course, if you have to do that, we have looked at like who does malware analysis and for what purpose. Now, this is basically uh, the goals and also the way that how you have to do it, right? So basically, so you have to do some preparing and training before do malware analysis. That's probably what I'm trying to do here. So to prepare you guys and also train you guys to do malware analysis. So we'll use a lot of tools, interesting tools within this process, right? So you can use things like GBB, whatever was used. Apart from that, you can go for other visual debuggers, and there are plenty of other specific, highly specific tools which will help on this process. And of course, the next step is to identify the malware. So that's probably is a harder step, but we'll try to understand how we can do that using proper tools. But of course, there are some concepts you have to learn before that. Of course, if you identify malware, you can stop malware being affecting, right? And of course, once you identify the malware, you have to contain it, right? So in the case of coronavirus, the containment, so we have to contain the malware, all right? So that's tremendously important. And once you can contain only, then you can even think of eradicating, right? So eradicating is the next step. So in the case of COVID-19, we haven't come to the phase of eradication yet because we don't know the mechanisms of eradication yet. But in case of this malware, of course, that can happen. Some of the zero-day malwares we don't know how to eradicate. So then the only option, like in COVID-19, even though it's biological, this is software based, it's like the same story, you have to contain it. So this is basically how to stop it, right? So this is really relevant to whatever it's happening right now in the outside world, right? And then of course recover. So there's so much of lost, so we have to recover as well. So in case of a ransomware or anything, there can be irrecoverable files. It's hard to say that. So you have to use some options to do that. And also finally, any malware analysis guide should have this particular goal in mind. So a lot of bad things happen. Sometimes you cannot stop things happening. So you have to have a phase of lessons learned, right? So if you don't have that lessons learned phase, so then you keep doing the same mistake over and over again. So it shouldn't be the case. Right. So these are like basically the goals to follow. So any malware analyst, reverse engineer, security engineer should follow these goals, right? So then you'll be in a good position, right, to fight with malware. Otherwise, it's like a very pathetic fight that we do. Like a lot of countries like USA, like you see, a lot of people, thousands of people have died. Same situation can happen. So you lose your data, you will lose your information systems, so all these things. Right. So basically, before you go to the analysis phase, just to know like how to protect from malware. So the protection hardening, you can use antivirus software. Right? So antivirus, of course, that's one product, and of course, there's more common generic products, anti-malware products. Right? So anti-malware, so that's also you can use. So malware bytes. So there are so many different types of products out there, and also you can use endpoint protection. So that's another cool methodology that you can use. IDS, IPS, HIPS, HIDS. So those endpoint type of protection can be used. So there are paid versions, hardware versions, software versions like Chromium and Cuckoo. So there are different types of formats out there. And also you can use things like virtualization, so which to help on malware protection, and also whitelisting, and also OS hardening, firewalling, content filtering. I'm not going to write everything. BIOS protection. So there's a long list of things that you guys can do to protect against malware coming in and eating you out, right? All right. So then now, okay. So now we are in a good position to understand now how we are supposed to do this thing called malware analysis. Right. So before, of course, like in the analysis, one of the major things would be to detect malware, right? So anyhow, you have a basic framework which you can use to do this process, right? So let us discuss this, and this particular image I have taken from this reference is already given, Android application security scanning process by these two people. Right. So basically now what you're seeing here is different types of detection techniques, and the first one, which is called the static analysis, which is so famous among most of us, and then dynamic analysis. So static analysis, more or less, you do look at the code and you look at the signatures, stuff like that. And then dynamic analysis, you run your code and then you can do emulations. If it's some software that you can directly run, of course, like this is malware, right? So you have to have these things called sandboxes, so to run these processes, right? So Cuckoo is one such sandbox for Android. So there are plenty more, right? So these are some of those techniques you can use. So static analysis is basically there you look at the static nature of the code. Whereas dynamic analysis, you look at the dynamism, or basically the process of actually execution of the code. So when it comes to static analysis, majorly, as you can see, there are three areas: signature-based detection. So you look at all the existing pattern, and then the permission usage, if there's any misusage of permissions, and then the dalvik bytecode detection. So this is popular in mobile security, especially Android. So now, of course, there is another one called AOT, ahead of time compiling, AOT. So that's also being used. So basically, we'll discuss this probably if time permits. So there are also, what we do is we do look at the bytecode and then analyze the static, or do a static analysis. And dynamic analysis, so you can do anomaly based by the way how the processes are running. So similarly, emulation based techniques can be used. So we can have a look at them later on. Right. So and also when it comes to static analysis, dynamic analysis, both situations you always get a basic type of one and also the advanced one. So dynamic also we have the basic and the advanced one, right? So next we'll try to understand these categories, what each category stands for. So in the basic static analysis, so what you find is it consists of examining the executable file without reading the actual instructions. So we look at just the executable file, and basic analysis confirm whether the file is malicious. Sometimes provide information that will allow you to produce simple network signatures and straightforward, quick, right? And largely ineffective against sophisticated malware. But the advanced one, you can use things like reverse engineering, right? So you can use reverse engineering in the advanced static analysis. You can load the internals, and then you can do a disassembly of the code, and you can analyze something internally within the CPU and other areas of the memory, right? So this is some common criteria that we use in the advanced static analysis. Now, if you go and try to understand the basic dynamic analysis, that's also having some similar features. So basic analysis involves running the malware and observing its behavior, right? And executing the malware setup environment, more like a sandbox. So if we try to talk a bit about here, so normally you won't be running your malware applications in your normal host. So we can use either virtualization, or we can use containerization. So you can use a thing like virtualization. You can think use a thing like vagrant boxes, or you can of course use a virtual machine. And vagrant boxes are easier to use, or you can use a containerized techniques like Docker. So these things also can be quite useful to run your malware code. So basically what you do is you can get a Windows box or a Linux box. So you have different options here. So there's two options actually, Linux based options, RE Linux, and few other options. And Windows case, you can get a normal Windows box, Windows 7 or 10, or even XP box, and then you can install software in it. And then you have to make sure once you install your stuff into the Windows box, this Windows virtualized box should be disconnected from the internet, because it can spread malware when you're analyzing them. And also you are going to connect it to the host just from the host only network, and it doesn't have the internet connectivity. So that should be the way how to handle it. And also FireEye, if you go to the FireEye website, they have given a nice library called FakeNet, so which you can use. It's available. I can provide you the links, and also we will do a practical using FakeNet. You can install FakeNet. It's a program library which you can run, and to download all the necessary software which you need to do malware analysis. So that's an easy way of preparing a sandbox, especially for dynamic analysis, right? Even for static analysis, you can use the same box with the software that you are required with. Right. So in the advanced dynamic analysis, of course, you can use debuggers and other things which is related. All right, so that's basically some options which are available to do malware analysis, right? Next, if we move ahead, so now there are few golden rules. As we say, there are some golden rules when you basically 3 golden rules. So you have to fix into some rules, otherwise you are going to be very mischievous at the end when it comes to malware analysis. So better to have set of rules basically giving you discipline, right? So the first rule, right, the first is don't get too much caught up in the details. So there are a lot of details when it comes to malware. So don't get into too details, right? So go with the basics, because if you look at the details, this you're talking about software code which can run for millions of lines of code, and it becomes large and complex in a given time. So what you have to do, what is recommended to do, so this is most of these things are taken from the malware analysis, practical malware analysis book. That book was somewhere there. I probably will show it to you later, and you can download it, of course, better if you buy it. So this book contains all these details. So don't go into too much into details. Look at the key features. Otherwise, you can get stuck very easily. Second one is use the right tool. There are so many different types of tools. There are no one single approach. So you have IDA Pro, you can have Win Debugger, and then you have P File Extractor, P File Explorer. So there are a lot of other other utilities which you can use. And also, given the situation, use those techniques as well, because if you don't use the techniques, you have to do things manually. It might take a long, it's a long time to find out details. And also there are different tools which give you different dimensions of the malware, so which is also good. So having look at the same problem or same asset from multiple viewpoints can be quite handy. So once you get the opportunity, do look at from multiple viewpoints, and so that feels good. All right, and also that will give out information pretty quickly. And the last rule, right? Malware analysis is like a cat and mouse game. What do you mean by cat and mouse game? So the thing is this: whoever is going to be fast, going to win the game. So thing is like we are finding out analysis techniques, and the malware writers are going to try to hide information. So if you use a sandbox, they know how to evade a sandbox. There are a lot of research being done how to evade a sandbox. So if you try to use a VM box, which is a sandbox, which is having these features where it doesn't have much of files open, then your malware would know, okay, fine, so this is a honeypot sort of environment, so I'm going to either get snoozed in, and it's not going to wake up, and then probably go out from the box. So all these things can happen. So it's quite important to play the malware writer. So that's the only way that you can detect the malware at the right time, and identify malware. And also this is keep happening, so you have to keep doing this for some time, because it's not a game where you can end it once you find the malware. All right. So what to do in a malware attack? So I'm going to talk about the incident response side of this, but again, this can be quite important. So now I have taken this particular images from Malwarebytes website. So they have this cheat sheet. So I'm going to show you one by one. So these are some of the tools which you can use. So for static analysis, of course, initially you guys have to work with VirusTotal site, and then you can identify whether you can upload a file to the VirusTotal, and then you can get an idea about if it is existing malware. So you don't have to redo it, you don't have to reinvent the wheel. So use places like VirusTotal, which is quite useful, right, helpful. Right. And then initial analysis, you can do PE Studio file analyzer. You can, if it's a Windows file, it can be a PE format, so you can use that. And also there are a lot of need to do string analysis, so a lot of hidden strings are there, so you can do that, right? And then of course under analysis environments, you can use VirtualBox, VMware, which is commonplace. And when it comes to dynamic analysis, there are some tools that we use regularly. So if I take this again, I'm taking this from the Malwarebytes cheat sheet. So you can use execution monitoring, registry file modifications, Redshot tool, and Wireshark Fiddler, and so you can get network traffic, and that also will help you. Right. So so those two are important. And under sandboxes, we can use different type of sandboxes. Cuckoo is one of the famous sandboxes, which you can configure and analyze. All right. So hope that part is clear to you guys. All right. Okay. Right. So now what we can do, let's check the time. Yeah. So okay, now we'll look a bit about like how to start this process. So when you want to start the malware analysis process, you can get go. Once you get go, it's quite easy to understand. But there are some theoretical concepts that are better to understand. So malware is generally of two types. So basically there are malware which is obviously obfuscated, right? So there's this term called obfuscated. So once it obfuscated, it's like it's encrypted sort of. And also there are non-obfuscated files, right? So once they are not obfuscated, they can be very well analyzed using static tools. But most of the malware these days are either tagged or obfuscated. So there's another term that comes in called tagged. So these two options are used by a lot of malware engineers, and also like this obfuscation packing concepts are used by some software engineers also to hide their code and things like that. Program obfuscation, there are cases where execution of the malware author has attempted to hide. So, and the packed programs are a subset of an obfuscated program in which the malicious program is compressed and cannot be analyzed. So, packed is basically a compression. To identify the malware is packed or not, we can carry out a static check. So once you do the static check, we can identify whether it's packed or not. And also, when the pack program is run, a small wrapper program also needs to run to decompress the packet file. So this is basically, I will give you a, so this is from the book Practical Malware Analysis. So as you can see, so this is the original executable, and there's a wrapper to run the pack or packer program. So there should be this wrapper to run the packer program. All right. Okay, so this is basically something that you know, but once you do a practical, you'll understand whether it's packed or obfuscated. So we'll have a different type of malware analysis strategy in that sense. So it is kind of useful. Right. So next, we'll quickly go through this portable executable file format. This is like normally the starting point of any malware analysis, because we are starting with Windows executables in exes, or the other one is of course ELF files. So we have done work, or we have done a lot of work with ELF, with bind exploitability and reverse engineering and assembly. So I'm not going to go detail into it again, because we are learning about the stack and the heap and the other things. So here we'll talk with, or we'll start with Windows executable. So portable executable file format, or the PEF, right, or the PE for that thing, PE or portable executable file format. It's used by Windows executables, right? So basically it uses by exes and also object codes, .objects files, and also the other one, dynamic link library. So all these buggers are used in the PE format. So it's a data structure that contains information necessary to run the Windows operating system. So basically, it gives the load information for the executable. And nearly every file with the executable loaded with the Windows is in the PE file format. So it's really cool, right? And for a few of the legacy file formats are not included, but normally yes. And also, if we try to draw the PE file format, so this would be the structure of it. So I'll try to draw as clear as possible. So we'll see it in this nature. So initially you will find some information, something called ms.stub. So we'll go to the details later on. And also then you'll have the header. So the header includes some information. So this is the header. All right. So header includes information about the code, type of application, required library functions, space requirements. So all these things are included in the PE header. And then you have the all important sections. So normally there should be at least one sections in this file. So under sections, you will find the basic stuff like the code, the text section, and the data, the imports, and the files, resources, and images, everything related to that running program you will find in the sections section. All right, section. Right. So so basically several sections are available, like I told you. So if I try to get some info from the book, so this would be the basic info that will be there in the section, right? So all right, if I go there, okay. So this is what you have. The text section contains executable code. Our data sections read-only data and globally accessible, right? If you can remember, this was discussed in binary exploitation as well. And stores global data access to the program, and this is our data is read-only. iData is present stores the import function information, where eData is about export function. And pData, so this is a bit different from ELF, Linux ELF, presents only 64-bit executables, and our SRC stores resources needed for the executable, and reloc is information about the relocation library files. So these are the things that you normally find in the section. All right, and then of course if I look at the header also is quite interesting in a PE file. So if I quickly take what information would be there in the header, so I'll try to put it somewhere here. So this is basically what you find in the header, right? Okay, so it contains useful information about for the malware analyst. So malware analyst can obviously read this guy or read this thing and can basically learn a lot of things. Yeah. So basically, as you can see, there are a lot of information: imports functions, exports, time data stamps, and also other names and subsystems like indicates whether command line or a GUI, and resources like strings, icons, menus, and other information, right? And also there are a lot of other link libraries, which is linked statically or dynamically, runtime linking. All these things are also there. So especially important to understand this about static linking, dynamic linking, and runtime linking. I'm not going to go detailed right now. So once we do a practical session, we'll try to understand these things. But these are some of those common DLLs which should be linked up in a file of this nature, PE file. This is common things that you find: the kernel 32 DLE, this ADB API DLE, Windows components of a service manager, user DLLs. Yeah, so then these DLLs come quite important. And also then there are a lot of functions. Again, there are plenty of different type of functions: import function, export functions. So there's a lot of functions, and also strings also there. So you guys have to understand all these things. And also you can see whether we'll do this practical, whether it's a packed executable. For that you can use a program, so and then it will so it's called tool called PEID. So this is something like that. So basically it provides you output, and it will show you it's a packer, right? Packer is available. So there's a UTX pack. So then you know that's it's a pack file and can be obfuscated as well. And there are other tools which you can use for the same purpose. All right. Okay, so that's probably uh, for the basics for malware analysis. Then, of course, the next session we can start discussing about. Yeah, so we'll first directly go to a small practical and try to see how we can identify some malware related stuff. Right, so then again we'll go into some theory. So there's a lot of content to be covered. So we'll start. All right.